Welcome. In this session, we'll demonstrate a complete Retrieval-Augmented Generation or RAG system built from scratch. The goal of this project is not just to use LangChain or LangGraph directly, but to understand every internal component of a production RAG pipeline before moving into advanced agentic AI systems. The workflow starts with a PDF document. The document is ingested, processed, cleaned, converted into embeddings, stored in a vector database, retrieved using similarity search, re-ranked for relevance, passed to an LLM, and finally evaluated using quality metrics. At the end, I will demonstrate LangGraph, agentic RAG, hybrid search, and future RAG concepts. So let's dive into the Jupyter Notebook from Anaconda. So this is the goal. Like in the earlier video, I have demonstrated the steps from PDF till agentic graph. So I will have a quick overview what's happening from the beginning. So these were my libraries used for the pre-processing techniques. For the PDF, we are using PY PDF. We were using Pandas, NumPy, and for personal identifiable information, we were using the libraries for text splitter, embeddings, vector database, RAG evaluation, agent framework, and last the visualization. So we are not using OpenAI. Instead, we are using OLLMA. So the libraries are installed over here. We'll go on to the next step. Like the first step is ingestion of my PDF document. Since it takes a long time to run each snippet, I was going with the output window. So my first step is ingestion of my PDF file, which takes the enterprise RAG banking architecture. This is stored in my local so that I can read and get the number of pages from this output window. And the second step is extraction. Like I'm printing the first 1,000 letters using a string. I'm embedding all my characters into the string and I'm printing the first 1,000 characters. Moving on, we have the statistics, how many characters, words, lines associated with the document. And then with the personal identifiable information, so which is used for every nation like GDPR, PII, General Data Protection Regulation. So to remove some of the sensitive data like emails, phone numbers, locations with respect to a person. And then we were detecting the sensitive data in terms of location, date, time. And then we are moving to the masking. So whichever data is sensitive, we are hiding it using the masking technology. Further, we are having the text cleaning, which results in removing the irrelevant characters of spaces, which is the current document. So before my character was 44,660, and after cleaning it was 44,049. Okay. There's a significant difference after text cleaning. So in the chunking, we split the document into n number of chunks so that we can utilize them in each pieces. So I'm printing the first chunk. It displays the first chunk, how the whole data is being into n number of splits, and I'm getting the display of first chunk. Later, we move on to embeddings. So the embedding is nothing but for each chunk, it converts into the numerical representation. We use this model sentence transformer and get this output. Later, we have the number of chunks, that is 98 chunks with the 384 features. We move on to the vector database from FAISS. FAISS is nothing but Facebook AI similarity search. We pass on the chunks and get the searchable index from that vector DB. Later, we ask the question as a prompt, and how do we use it in the retrieval to see the similarity search. From here, we can see the indices, how it gets the output. Later, we use the sentence transformers for cross encoding and also for the re-ranking. Later, we have the context building to print the first 1,000 characters. Instead of passing the whole text to the LLM, we pass on the appropriate text to the LLM. So this is the text which is being passed to the LLM to get the result. Later, we have the LLM generation. In this case, we use this local LLM. Okay. So this is my LLM. And I have the local API by passing on the relevant parameters. I get the output here. And then we follow the metrics for ragas. We use the sentence transformers with the SAA kit learn, and then implement the ragas to get the metrics. Okay. So from the question, context, and answer, how do I get the metrics in terms of faithfulness, and then the answer relevancy. So further, we'll move on to this step of LangChain, LangGraph, Agentic RAG, Autonomous RAG, Hybrid Search, and Graph RAG. Okay, these spaces which has been left from the previous session. So we'll look on to this detail because those were the pre-processing steps which were involved from step phase 1 to phase 14. So phase 15, this is LangChain integration. So how do we utilize this in our Jupyter Notebook? So as you can see, this is the LangGraph workflow. So typically what happens is when the user asks the questions, it will be having the analysis of the query. It retrieve, re-rank, evaluate, generate the answer, review the answer, and response. So, this is the typical traditional RAG. So, when we ask the question, it goes to the workflow graph and the answer. So, we have the LangChain over here. We are cross-checking what version of LangChain is being utilized over here. So, our version is 137. Okay. So, we are running a sample LangChain program to understand how it's processing our prompt. And then it retrieves the first 500 characters. So we ask the question and we get the answer over here. Similarly, we have the sample local LLM API to get the response. Further, we were using the request and time. Since I was taking too much of time to get the response, I was utilizing this way so that it retrieves quickly by having the time difference, how much time it takes from start time to end time, and then I'm retrieving the answers from here. So to deep dive on the LangGraph, we were using the single node, double node, and 3 nodes to find the differences. So what happens, whatever questions we ask to the LLM, instead of going to the LLM and get the answer, it chooses the tool, which tool to be executed based on the question. So for example, when we ask what policies to be followed in GDPR or personal impact, personal identifiable information, and then the privacy impact on individual. Instead of going to the LLM and response back, we will have which tool to be used based on the question in terms of finding the score, confidence, and with the metrics, we can understand how autonomously we can make the decision. So that's what happening in LangGraph. So we can see the single node. This is the exact example of single node, how we are utilizing the workflow node and then the graph and getting the result in the LangGraph. We will see the explanation of node workflow and then why it's been used later after completing the 3 nodes. So this is the example of a single node which has the grid. It displays it. So this is the example of 2 nodes where we have the functions to choose between the retrieve and generate. And so we use this program to understand which function it calls based on the question. So this is the example of 2 node. And this is the example of 3 node. So based on the 3 functions, which tool to be executed. Like that, we can have the decision making in the 3-node function of LangGraph. So, the questions which is on node, what is a node means? A node is simply a function. What is state is? State is the data moving through nodes. So, edge means what should I do next? It defines the path. And the workflow is the complete map, like how the flow happens from start to end. So why it's important for agentic AI means it thinks, chooses the tool, execute the tool which is being selected, observe the result, think again, and next action. So it is about making decisions autonomously. So as we see, the score and confidence is very much required on LangChain, LangGraph, autonomous agentic AI, and then in the hybrid RAG also, since it determines whether a human should be in the loop or it can able to answer it with the help of the score and confidence. So score is nothing but the numerical measure from retrieval or evaluation, and confidence is about the system belief that the answer is correct, often derived from retrieval similarity, answer quality, faithfulness, or a combination of these metrics. So the score and confidence is much needed in terms of metrics from LangGraph and LangChain, and for the autonomous RAG. In the agentic RAG, what we do is, in the traditional RAG, we ask the question, retrieve, answer. But in the agentic RAG, what happens? The agent thinks which tool to choose, and then retrieve and then answer it. So this is the example. We have the function over here for security and monitoring. So in this program, I'm asking a question from the prompt. So we can see the program over here. And my question is, from the output window, I was asking business data needs GDPR. So what happens? It chooses that particular tool and responds to my question. So this is my answer. So how it utilizes on the local LLM. Further, we have the autonomous RAG. The agent can retry it automatically instead of waiting for further instructions. So here we ask the question based on the retrieved context, and we have the prompt here. We use the local host API with the parameters of my local OLLMA model with the prompt and stream. So I have set the confidence. If it is less than 0.7, we follow this if condition. Later, I was asking the question monitoring in banking, since banking, insurance, and healthcare are sensitive to data security policies there. So governance and policies being there in those domains. So we get the result attempt 1. How much is my confidence score, the low confidence and the final confidence, and the answers to this program. Finally, we have the other hybrid search by using Facebook AI similarity search, and then with the BM25. So we are installing the library rank-BM25. Once we install that library, we have this program to run on the hybrid BM25 scores to know how much it utilizes on the score for BM25. Further, we have the encoder. We set that parameters with question vector and k variable, and then we get the output. Later, we have the hybrid results from the indices. So we get the output over here. Finally, the RAG graph, which was used for relationship retrieval. We installed the library using Network X. So we use the graph in terms of the age security and the MFA, IAM user access. So how it is printing by using the neighbors. As well, we have the question related to security. So it uses the local LLM and gets the answer. Finally, we have the metrics. What is the metrics used for latency based on the question, and the confidence score with the latency. So this is a simple overview how we can utilize a document in the ingestion and get the entire flow, like a phase 1 to phase 20 to understand and scale it to next level. So this is not something about you can put use it as an enterprise RAG. Instead, you can understand what's happening from RAG phase 1 to phase 20. So that's what this overview is about. And this is the mind map which helps us to understand what's happening in the different phases, just for the quicker understanding. So to have a conclusion, this is the overall steps which is being followed. Initially, we upload the PDF file. It is following ingestion statistics, the reduction of PII and the masking, and we clean the text, chunking, embedding, vector DB of Facebook AI similarity search, retrieval, re-ranking, context building, LLM generation, drag evaluation, and then we use the LangChain, LangGraph, Agentic drag, hybrid drag, autonomous agents, and then finally with the metrics. So this is the overview. So thanks for your time.